Intermediate Algebra Section 11.2. In an arithmetic sequence, or sometimes called progression, adding the same number to any term gives the next term in the sequence. For example, consider the sequence shown here, 2, 5, 8, and so on, is arithmetic because adding 3 to any term produces the next term. 2 plus 3 is 5, 5 plus 3 is 8, and so on. So we have a definition for an arithmetic sequence. A sequence is arithmetic if there exists a number d called the common difference such that a sub n plus 1 is equal to a sub n plus the common difference. In other words, to get to the next term, you take the previous term plus that common difference. And the example we had a common difference of 3. So we were adding 3 to the previous term to get the next term in that sequence. If we're after the nth term in an arithmetic sequence with a common difference, we can use the following formula. A sub n is found by taking a sub 1 plus n minus 1 times the common difference for any integer where n is greater than or equal to 1. So let's do some practice given these arithmetic sequences to find the first term and the common difference. Well, the first term is pretty straightforward. It's 4. Common difference is found by taking a term and subtracting the previous term or its preceding term. So 7 minus 4 gives us 3. To verify that, 10 minus 7 is 3, 13 minus 10 is 3. So we can feel pretty comfortable that our common difference is 3. We have another one asking for the same information. The first term, a sub 1, is 20 in this sequence. What's the common difference? Take a term and subtract the previous one from that. So we'll take 17.5 minus 20. We do end up with a negative, and that's, as you can see, our sequence is getting smaller, so they're adding a negative number to make that happen, and that common difference is a negative 2.5. Again, it's always a good idea to verify. So if we do a test here, 12.5 minus the previous term, we end up with the same negative 2.5 as well. We then can use that nth term formula to help solve problems that look like this. They're asking us to find the 12th term in this arithmetic sequence. So we have our first term, negative 4. Our common difference can be found by taking 1 minus the preceding term. Minus a negative is the same as adding 4, which ends up giving us 5. And again, verifying that, 6 minus 1 is 5, 11 minus 6 is 5. Well, to find the 12th term, we could start adding 5 to each term. Here we are at our 4th term. 11 plus 5 would be 16. That's our 5th term. 16 plus 5, 21. You know, we could continue on to get our 12th term. But we also can use the nth term formula, which is a sub 1 plus n minus 1 times the common difference. So we're asked to find the 12th term. That means our n is 12. We identified our first term as negative 4. We're after the 12th term, so n is 12 minus 1 in the formula times the common difference, which we found to be 5. Simplifying this following the order of operations, parentheses have the priority, so we have an 11. Next we'll do our multiplication. So we have 11 times 5 is 55, and then adding our first term to that ends up the 12th term in this sequence. If we kept adding 5 onto each preceding number, we would end up with 51 for our 12th term. In this next problem, they're giving us kind of a mystery and asking us to find the first term and the common difference, and they're giving us the 4th term and they're giving us the 15th term. If these terms had been adjacent to one another, we could have found the common difference, and once we knew the common difference, we could have solved for a sub 1, but they're quite a difference between the two terms. How was the fourth term found? Using that nth term formula, our fourth term, which we know is 23/2, was found by taking the first term, we don't know, plus n minus 1, and our n would be 4, since this is the fourth term, times the common difference, we don't know. Simplifying this, instead of working with the fraction, we can do a division. That gives us 11.5 for a decimal equivalency. A1, 4 minus 1 is 3d. We have one equation with two unknowns. To solve an equation with two unknowns, we have to have two equations. So let's look at the other piece of information. Here's our 15th term. How did they find the 15th term? The 15th term, which we know is 17, was generated by taking the first term we don't know, plus n, 15th term, minus 1, times the common difference, which is unknown as well. Simplifying here, 17 is equal to a1 plus 14 times the common difference. We now have a second equation. So if we take those two equations, 11.5 is equal to a1 plus 3d, and 17 is equal to a1 plus 14d, and add them together such that one of the variables cancels out, we can solve for the remaining variable. So before we add these together, it'd be nice if this a sub 1 was a negative. So to make it negative, I'm going to multiply every term by a negative 1, doing a linear combination procedure on our two equations and two unknowns, and now I'm ready to add. Negative 11.5 plus 17 leaves us with a 5.5. The a sub 1's cancel out, that's what we wanted. And negative 3d plus 14d leaves us with 11d. We have one equation with one variable. Solving for the variable, dividing both sides by 11, leaves us with a common difference. 5.5 divided by 11 is 0.5. So we have our common difference. We now can plug that into either one of the equations. I'll do it right here to solve for our second variable we're looking for, the first term. We don't know the first term, but we now know our common difference of 0.5 that generated this 15th term. Doing the multiplication, 14 times 0.5 or a half leaves a 7. Subtracting a 7 from each side leaves us with the first term is equal to 10. So here is the first term in this arithmetic sequence, and here is the common difference. And you could verify 10 plus 1/2 and continue on so that you get your fourth term. And if you wanted to really verify, using the generic nth term formula, using the first term of 10 and the common difference of 0.5 should result in the 15th term being 17.